Our next speaker for today is Swanand. He is the principal engineer at First IO and a fellow member of the community for a long time. He's one of the organizing team for Garden City RubyConf and wants to talk about graph databases. So, Swanand, over to you.
Thank you, Sidhu. Hi, everyone. Welcome to the talk called How to Cure a Hangover. Well, I wish after a party like yesterday, hangover is the biggest thing on my mind typically. But not today. Today I'm going to talk about graph database. So you might be wondering, like, what the heck is a graph database? A graph database typically is a database that allows us to model our data using graphs as opposed to, say, documents or tables like MongoDB or Postgres do. Graphs in general are known as most generic of data structures, and they allow for some very powerful abstractions for our data. And we'll see more about that later today. But let's begin with something, a confession. That's right. What I want is, like, I don't really want to sell you a graph database. I mean, my talk's title is that I want to sell you a graph database, but that's not what I really want to do. I want to sell you the idea of a graph database. Like that a graph database is not out of consideration when you're making a choice for your database. And why is that? Let's consider this quote, very, very famous quote by Alan Perlis. A language that doesn't affect the way you think about programming is not worth knowing, right? So allow me to paraphrase him a little bit. A database that doesn't allow you to, or doesn't affect the way you think about data modeling is not worth knowing. If our database is not forcing us to rethink our choices, then I think that database is not really worth it. And the attitude that I have an app to build and I'll just get on with Postgres and go ahead and build it, I think is slightly harmful. So what I want to help you do is to make an informed choice. And before that, let's begin with a quick story. So my team at First.io, we spent the last 1 year building a product using Neo4j. And we spent 1 year building a product users pay for, a product users love. Along with Postgres, of course, we use Postgres. Redis, the standard Rails stack. But our application was centered around Neo4j, right? The schema-less, relationship-focused nature of Neo4j allowed us to take great strides and come up with proof of concept applications or what was it called? VP or MVP, like get it out of the door fast. And and we chose Neo4j because at our heart, the data is about people and relationships. We are into real estate domain. We make product for realtors. And at the heart, the data is about people and their relationships. And so Neo4j felt like a natural choice. But now, we're actually rewriting the app in Postgres. And this may probably come as a surprise, but our team basically concluded that both the decisions were correct. Like using Neo4j back then was right, and using Postgres now is also right. So, I mean, why do we think that? I think the fun is usually always in the details. So let's look at these three things in particular and how they shape our choices of the databases that we make. Semantics, tooling, and ops. So by semantics, what I mean is modeling and querying with a graph model. Tooling is what kind of libraries we have, what are the admin tools at our disposal. And then finally, ops, deployments, monitoring, infrastructure, etc. So without further ado, let's jump into semantics. What do I really mean by modeling and querying data? Or what is semantics really all about? It really boils down to this one question, that does it make your business logic any better or any simpler, right? Writing cleaner, simpler code, well-testable code is a major goal. That is one of the primary goals of an engineering team. And turns out a graph database like Neo4j does make our business logic simpler and better with better abstractions. And we'll see how through a few examples and a couple of other things that I want to share today. So let's get our hands dirty with the first example. symmetrical relationships. So, for example, representing marriages, right? Marriage is a symmetrical relationship. Say a person is married to one person, then by definition, the other person is married to that person. I'm married to my wife, and I sure hope that she's also married to me. Otherwise, that's the problem. So the traditional way to solve this would be a joint table. So like I said, the traditional way to solve this would be a joint table. You put the person 1 ID and person 2 ID in a row, and then you perform simple queries around it. And it works. It's a very simple solution, quite standardly used, but it calls for some awkward querying and awkward code. Or in some cases, if you try to build a robust solution, then some additional complexity. So for example, this is a classic has many through example. A person has many marriages and has many spouses through a marriage, and a marriage belongs to a person and spouse. This should be familiar to most Rails developers out here. Like, I'm pretty sure everybody has built something or something similar in their life cycle as a Rails developer. And so should this be familiar, right? We want to run a query against two people, then we want to look up person ID or spouse ID, right? And if you add one row per marriage, then this is the result. And like I said, it really calls for some awkward kind of code, right? What was the partner you were looking for? Was it the person or was it the spouse? We get some really awkward code, like awkward. But hey, this is Postgres, so I think we can certainly do a little bit better. For example, we use two rows to represent a marriage. And so if there is person A married to person B, then person B is also married to person A. And with a little bit of Rails API, we can do this, always create an inverse on after create callback. This is good, it works. I think it's a fairly clean solution, but there are a few caveats. Like for example, if you go with this approach, we have to always make sure that our database, the table we are using to represent marriages, always has an even number of rows, right? If there is ever an odd number of rows, then that's a problem. Then additional features, adding some more complexity to the domain makes things far more complex. Like for example, if you want to maintain past relationships, or like people maybe were married at some point, they're not anymore, or they're separated, or there are various complexities. Or like having multiple spouses at times, at the same time. I mean, group marriages are not unheard of in the world. Like many people could simultaneously be married to each other. And so if you add complexities like this, this simple looking elegant solution starts adding some more complexity, like more complexity than I'm prepared to deal with. So compare this with something like graph, right? How would we do this in Neo4j? So the solution looks something like this. There are many things going on here, but I want to focus on line has many both spouses, specifically the keyword both. What this is doing is it is telling Neo4j that whenever I create a node that a person marries another person, that relationship is bidirectional. Right? As soon as I connect those nodes, Neo4j knows that this is a bidirectional node, and then the relationship is expressed bidirectionally. So no maintaining even rows or no adding callbacks to ensure that this happens. A clean, simple declarative style of declaring a bidirectional relationship, and we are set. So what we have done is we've just represented a perfectly symmetrical relationship using a declarative construct. And declarative style is one of my favorite programming paradigms, so to speak. My functional programming friends from the crowd would attest to this. Like Scheme fans, for example, or Haskell fans, they lay great importance on writing declarative code. One of the strengths of Ruby is being able to write code that looks like the problem you're trying to state by hiding a lot of implementation details. So that is about relationships and bidirectional relationships. There are a few more things going on in this slide, specifically this part. What we are doing here is a person has many spouses, but we have also created an ad hoc pointer to the current spouse. So whenever we want to query for the current spouse of a person, we don't really have to look at all the spouses and like filter them. We directly have a relationship between the person and the current spouse, right? With Neo4j, you can create ad hoc pointers between any nodes. And this is the same part of the schema-less design that I was referring to earlier. Anyone who has worked with maybe Mongoid should be right at home with schema-less design, right? So pointers, what do I mean by ad hoc pointers? They basically mean edges or relationships. What we are doing is we're just telling that these two nodes are connected, and then this is the label that we want to give to their relationship. And there are plenty of use cases for this, and this is an incredibly powerful construct. So that brings to the next semantics, what I'm calling as ad hoc pointers. So let's say the author has many books, and we always want to know what the current book she's working on, so, right? So that could be expressed using this. Or for example, student has attempted many assignments, and we always want to know what was the best assignment out of those, right? Or for example, dentist treats many patients, but only one ends up teaching Ruby to her. So the one change from earlier examples and in this is that the relationship defined here is incoming. So that is another semantic that a graph mandates or offers, is that the relationship could be directional. And just like earlier, we can declare the relationship to be either incoming or outgoing. So these were slightly pedagogical or maybe contrived examples. This is a real world code that I'm currently working on. This is taken from our product. Each person has many move scores. We run scoring batches every month. And so every month a new score for a person comes in. And whenever we want to display or use that somewhere in the product, we always want to know what is the most relevant or the current move score, right? The current move score may or may not be the one imported latest. It could be from an earlier batch that our data scientists feel was more accurate. So what we want to do is, like in typical in RDMS, you would probably set a flag on that row and maybe query based on the flag. One of the perils of using data or modeling data as tables is that we always tend to think in terms of properties. Like we have a node or a table or a row, and then we have columns. And that limits our thinking to just thinking about data and its properties. What graph is offering us is node and the relationship and then the properties on their relationships, right? So for example, when you're doing something like this in Postgres, either you have to add a column in the row to actually point to that row so that you can write like a belongs to sort of a query. Or you have to actually, when you run a query, then you have to like write group by clauses, sort them with the relevant parameter, and then select the one that you're looking for. In general, very complex. And for example, if you want to play around with this in production or any of your data, you won't be able to add columns ad hoc to Postgres. Right? If schema changes are non-trivial in any relational database, you'll have to make a deployment. You have a formal process for rolling out schema changes. And so the schema-less design in Neo4j and being able to add ad hoc pointers like really helps. It allows us to write very powerful queries like this, for example. Don't worry about the syntax too much here. I'll mute it for you. What the query is really representing is this. Match in the entire graph database, match something like that looks like this graph, a node, edge, another edge, and then node. And return me all the patterns that or all the data that matches this pattern, and then filter it with a conditional, and also filter it by this another pattern, which is also a graph, right? So what is really interesting about this is that we are able to write queries about graph data using graph data. This is exactly what I mean about being declarative. So if you're writing queries on tables and rows, you're not really, like there is not a lot of parity between what you do and what you have, like the queries you write and the data you represent. And that is one of the core strengths of say Neo4j, that it allows you to write this kind of stuff. It's beautiful. Like, I love it personally. Let's come back to this example a little bit. Like I said, there are some more things going on here, and I'm specifically interested in this, right? So what this is polymorphism right here. What the code is declaring is that a person has a has preferred relationship, and we don't really care what it is pointing to, right? Star, like a very popular, well-known wildcard character. So this is what I'm calling as polymorphism. This should be familiar to most Rails developers. Remember this? Acts as commentable or belongs to commentable polymorphic true. Now, I may have liked this solution at one point of time, but I think this is a hack, and nothing better than a hack. Good luck writing join queries against something like a polymorphic relationship in Rails. Not that it's impossible, mind you. You can query for all the distinct types of polymorphic columns and then run a complex join operation based on the values. So it is possible. And that brings me to a very important point that I want to make, is that Neo4j or any other graph database at this point is a pure subset of Postgres. Like anything you can do in Neo4j, you can do in Postgres, right? Postgres is like the big brother, or MySQL is like a big brother of all these databases. So, but you know what? Everything that Ruby does can also be written in C. But we don't write our apps in C, do we? We write web apps in Ruby. We love Ruby, right? I'd rather fight 100 duck-sized horses than write my web app in C. Which brings me to my next semantic, labels. So labels or polymorphism, mixins, and composition. Extremely powerful, and this is perhaps the second biggest draw of using Neo4j. So each node in a graph is identified by a label, and each edge in a graph is also identified by a label. Similarly, any node in a graph can have any number of labels, and any edge in the graph can have any number of labels. Same. So they both have first-class support. And this actually is, again, like I said, a very powerful construct. I'll give you a quick example about labels. Back in the day when Yahoo Mail was popular, there were a concept of folders. People would filter their mails and mail would go to different folders. Then came along Gmail with the idea of labels. And the biggest change was that same email could exist in different labels, right? It was a groundbreaking change. Something that caused the high popularity of Gmail in the early days. So, but how does that really help us in our data or our app? Well, let's equate a label to a class. Like for example, email, phone, and contact info, right? They're all a part of the same data. So email is a contact info, or phone is a contact info. So we have some shared behavior, right? If I want to look up a person, I could look them up by phone, or I could look them up by email. But different constraints. Like for example, I may want to enforce uniqueness on email, but I may want to relax the uniqueness criteria on phone. Or I may want to enforce formatting on phones. Or I may want to ensure only valid phones are represented. Maybe not like that for email. So they have different constraints. And currently, different constraints are not possible in an RDBMS, right? If you put data in the same table, then the same constraints apply. Again, like I said, it's possible, but not without a lot of additional complexity. You can set up check constraints in Postgres that act on the value of columns, and you can have complex constraints that behave differently for different rows. And so that'll work. And it just goes against my point that Postgres really is the big brother, but Neo4j allows us to write things more semantically, more in line with what the business logic is. And so case in point, why I think labels are important is that they allow us to write powerful small modular classes that represent the same underlying data, and yet the concerns and code is separate. So instead of writing a big class called person, you could write smaller classes for employee, dentist, student, etc. Have self-contained classes that adhere to principles like SRP, and write highly modular, high-tested code that works no matter what. And this is a good thing. This is, like I said, this is one of the most powerful things that I find about Neo4j. So let's go to the next example. 6 Degrees of Kevin Bacon. Anyone heard of this game? Can you raise hands? 1, 2, Okay, there are a few hands. So this game was like inspired by the inspiration to come up with this game came to a few scientists when we were watching this amazing film called Footloose, one of the greatest cult films of the 80s. If you haven't, go watch this awesome film. I'm not really going to explain what bacon number is. All of you have devices here. There's Wi-Fi. Go Google it. Google your actor's favorite bacon number or favorite actors like bacon number. For example, Sanjeev Kumar's bacon number is 3. Don't ask me who Sanjeev Kumar is. He's the Thakur from Sholay. And so if you imagine something like this, how would you represent this kind of data? The graph looks something like this, right? Actor has worked with actor, has worked with actor, has worked with actor, and so on. And there are different kinds of relationships. Maybe you can add different labels like was director or was producer, was music composer, etc. But the case in point is that the same kinds of nodes have different kinds of relationship, and they're related to each other by more than primary relationship, like tertiary, secondary, tertiary relationships. And so if you think about representing this in Postgres, I encourage you to try and come up with a solution for this on your own. It is non-trivial to set up tables to work with this, non-trivial to set up queries that efficiently can query this kind of data. If anyone has taken an algorithms class here, they would probably guess that this is an example of a problem called union find, non-trivial again. So how do we actually solve this? Well, answer to this question has been left to the reader as an exercise. And I'm only half joking. It's not really that difficult. Like, literally, if you go to the Neo4j website, on the first page, you have an example, which is pretty much similar to 6 degrees of Kevin Bacon. Like, you're trying to match, you're trying to find an expert who has worked with Neo4j within your network. And then you have constructs like shortest path and like graph. So I'm not going to go into details of this, literally available on the website with much more detail. And this talk, I don't want to make this talk into a tutorial. You can read about this. And the case or point I want to make is LinkedIn, Facebook, they get or they deal with these kind of queries every microseconds. So plenty of more examples and great documentation on the website about Cypher and querying with graph. Reading through the examples will immediately make it clear that Cypher is a much more powerful language and far superior to SQL in many ways. In some cases where it is inferior, it is mainly because what Neo4j does not support or does support. And so this was about the semantics of a graph database, right? What it allows you to do as a data model and what it doesn't. And I assure you that if you have relationship-focused data, you will write better code using Neo4j. I guarantee it. So that brings me to the next section, tooling. By tooling, I mean libraries, adapters, dev tools, admin tools, etc. So the first question that anyone may have at this point is, if I want to write an app, like, is there any active record? Like, we are too used to active record or Mongoid or like whatever your poison of choice is. And so the answer is yes and no. There's a Ruby gem called Neo4j, which is available. No, because it is not quite as fully featured as active record. But yes, it offers that well-familiar API that we have seen earlier, right? We saw this slide, has many, has one. These things are familiar to us. And yes, it offers all the tools we are well acquainted with. Like, for example, properties, indexes, constraints, callbacks, validations, associations. So these are all the things we use every day to represent our business logic. And so this tool offers us all these. But of course, like, there are caveats. If there weren't, I wouldn't be talking about this. So for example, Neo4j does not maintain types of properties, right? And so because Neo4j doesn't, Neo4j.rb has to, right? We can't have untyped properties in our code. If something is a date, then it's a date. If something is a string, then it's a string. And so there is an additional cognitive overload when we are writing queries. For example, that's a sorted collection, and so is the other one. And specifying type on the data makes all the difference. Another caveat is that Neo4j does not allow composite indexes. This is, I think, one of the primary reasons why we started thinking of switching to Postgres. So when you don't have composite indexes, then you're reduced to hacks like setting up a dummy column, which is a concatenation of multiple columns, and then putting constraints and indexes on that column, right? Not very clean, like harder to test, and there's additional complexity. Like I said, I don't like additional complexity. I like to keep it as much close to the business logic or specification as possible. So, and the other reason is that I also like to depend on my database to ensure integrity of my data. Indexes, database constraints are like very important to me personally, and I think they should be very important to you as well. Like for example, if you're validating uniqueness, you better set up a unique index in database and not rely on Rails to do the uniqueness check for you. So the other thing that bit us was Neo4j does not support did not support a binary protocol. It was all REST-based. And so the good thing is that REST will allow you to write adapter-free clients, right? It's just HTTP. So build up like curl queries to your heart content or build a simple HTTP-based REST client. And you can make queries and to your heart's content, use the adapter, all works well. But the main caveat is that HTTP client management is extremely hard. Do you use connection pools or do you use persistent connections? Do you use both? How do you deal with the effects of TCP handshake, latency, and the entire overhead of HTTP? All of it makes it a giant pain. Like anybody who attended yesterday's talk or unconference about distributed systems would have heard from our moderator that what kind of pain HTTP can be. Right? When we are talking through database, we want to make it fast. But like I said, it was REST-based because it is being addressed now. A binary protocol is out. I wouldn't call it production ready yet because our team is not ready to use it in production yet. But it will be in a few years. And you can always use the JDBC connector from Java. It is fast. It doesn't suffer from like issues like the Ruby adapter does. So what particular issues? So for example, when we're using Neo4j with Ruby, you will find tons of these errors. Neo4j cipher error, and these errors, and these errors. And they occur far too many times to count, right? HTTP clients do not scale well. Like anybody who claims they do, I think they've probably not worked at a scale that matters enough. These errors were our primary reason to switch out of Neo4j. They crippled our scale, they limited our concurrency. So we use Sidekick for bulk of our processing. And most of the computation in our app happens in Sidekick. And Sidekick is an amazing tool. It's fast, like it's too fast for its own good. It's blazing. We love Sidekick. We even purchased the enterprise grade support they have, the enterprise version. Full of great features, amazing speed, but we cannot use that speed. You know, our errors with Neo4j are limiting us to use Sidekick in a very limited way. And basically, like I said, they cripple our scale and our ability to move faster. So that's a big deal breaker, right? I can't have that. And so these two things, like data integrity and these issues with the Neo4j adapter, they kind of forced us to go back to the drawing board and think, and like made us think about switching to Postgres. And we concluded that, yes, it is time to move to Postgres. But mainly because we were moving at a fast pace. So for example, in the next few months, we are expecting about 50x increase in our scale, right? And if you're expecting 50x, then we need to at least plan for 250x. Like you have to plan for 5x the scale you're looking at. And so these kind of things are a deal breaker. So there are plenty of more things that I would love to talk about. I'm unfortunately out of time. For example, I mentioned this, monitoring backups, etc. But I'll stop here for now. I think the main point I wanted to make was about the graph semantics and the tooling and libraries. And I think I've made it. If you want to talk about more of this stuff, catch hold of me at lunch or after the conference. I'll be happy to discuss these things. Like, I can talk about this endlessly. This talk is like a result of last 1.5 years of work that we have been doing. And I have like plenty more insights to share. So happy to talk about. So if we were to draw some conclusion, I would say Neo4j offers powerful querying, excellent performance for queries, a beautiful API, and great semantics. Right? You can write graph queries using graph data, and it makes it a natural choice for building applications with relationship-focused data. And really, relationship-focused data, I'm saying it like it's a special thing. If you think about any data, like just go back to your application data and it would be relationship focused. We don't really use like separate or lumped data so much. So a natural choice all works well, but the Ruby ecosystem and tooling leaves a lot to be desired, right? I would say the maturity of the tools we have in Ruby ecosystem today is not enough to warrant this as a choice when building a high scale or high concurrent application, like for example, specifically when we are dealing with high concurrency. So that's the conclusion I want to make. An excellent choice when it comes to semantics and querying, but the Ruby ecosystem of Neo4j leaves a lot to be desired. So that's it. Thank you. So I am. I think the feed got cut off. So I'm Swanand. I work for a principal engineer at First.io. These days, I identify more as a father. As my daughter, she's 9 months old. You can catch hold of me on Twitter. I'm _Swanand. And if time permits, I'm happy to take questions. Thank you for listening, the one who is asking questions.
Sorry, I saw a hand here somewhere. Yes.
Hi. So what was the reason that you moved to, again, back to Postgres? You said if the database has a constraints directly on the database rather than relying on the Rails method. Right. So if you would have had the constraint on the database, wouldn't you have reconsidered going back to Postgres, or you would have stick back to Neo4j?
Good question. So that was one reason. So data integrity is vital. Constraints are just one form of ensuring data integrity. And so, like I said, they are a very important factor to be considered. Specifically when your app is data focused, like ours is, data integrity becomes the number one concern. And like you said, if Neo4j supported composite indexes or check constraints and other like stored procedures like Postgres does, we would have not thought of switching. Or at least it would have weighed in favor of Neo4j.
I saw one more hand here. We have 5 more minutes.
Hi, Swanand. Hi. So when we talk about the performance, do you have any like benchmarking statistics against traditional RDBMS? And the second question is, what are the all ideal scenarios where I should go for the graph database?
Okay, great question. So about benchmarks, like there are plenty of benchmarks on the Neo4j RB. Also, if you go to Stack Overflow, there are a couple of regulars who regularly post benchmarks. What the general consensus and findings are that if you are querying for a single node of data or a set of data related to single person, like maybe one person and that person's social profiles, that person's connections, etc., Neo4j performs significantly better. But the performance for batch querying, where you have to query for thousands of records at the same time, it suffers as compared to a traditional RDBMS. But these benchmarks are slightly biased to make Neo4j look better. I think it will be a couple of years before a graph database can truly compare the raw performance to something like Postgres or MySQL. Like MySQL can scale and perform like crazy. It has insane amount of optimization, decades worth of research behind it. But like I said, for single record data, the performance is comparable right now. And what was your second question?
What are ideal scenarios where should we go for the graph database?
Okay, so number one is your data about people? Then it is graph database becomes a natural choice. But I would encourage you to literally draw your entity map on a whiteboard. You know, like map out relationship, like what are various nodes or what are various entities you have in your system, and then what are the different relationships. If you have any ratio of 1 to 1 between your entities and the relationships, then that is a candidate for a graph database.
Any other questions? I think we have time for one more.
Nice talk, Swanand. So what did you do with your existing data when you moved to Postgres?
So right now we are in transition. So this week is our deployment week. We are in transition. So from Neo4j to Postgres, the data remains in Postgres, and then we have written migration scripts for individual users to migrate them over to Postgres. And I mean, once we have migrated all the users, we will purge that data and like get rid of Neo4j. We'll also be deleting a ton of code.
Nice.
Okay. Anybody else? Okay, super. Thanks so much, Swanand.
Thank you.